Welcome. PIO 205. Study Section 4. Cardiovascular System. Introduction. The cardiovascular system consists of the heart, anatomical pump, with its intricate conduits, arteries, veins, and capillaries that traverse the whole human body carrying blood. The blood contains oxygen, nutrients, waste, and immune and other functional cells that help provide for homeostasis and basic functions of human cells and organs. The pumping action of the heart usually maintains a balance between cardiac output and venous return. Cardiac output, CO, is the amount of blood pumped out by each ventricle in 1 minute. The normal adult blood volume is 5 liters, a little over 1 gallon, and it usually passes through the heart once a minute. Note that cardiac output varies with the demands of the body. Learning outcome for study section 4. At the end of the study, you should be able to describe the circulatory cardiovascular system, explain cardiovascular terminologies, explain the conducting systems of the heart, explain the term electrography. Circulatory or cardiovascular system. All vertebrates have a closed circulatory system which is made up of a single heart and 3 types of blood vessels. The heart. This is made up of 2 main kinds of chambers. Atrium, which is a thin-walled chamber that receives incoming blood from the body. This is divided into 2, the left and right sides. Ventricle, a larger, more muscular, thicker-walled chamber that pumps blood into the body. This is divided into the left and right sides. The human heart is divided into 4 chambers, that is, right and left atrium, right and left ventricle. The atria and ventricles have one-way valves that allow blood flow only in one direction. This valve is called atrioventricular valves. The 3 blood vessels are arteries. This transports blood away from the heart. Veins transport blood back to the heart. They also have or contain one-way valves which aid in the return flow of blood to the heart. Capillaries have walls which is only 1 cell thick, so material can pass easily in and out of them. Blood picks up digested food molecule from within the capillaries in the intestine and picks up oxygen from within capillaries in the skin. As the blood in the capillaries pass by cells, food and oxygen in the blood pass through capillary wall to the cells, while waste pass from the cells through the capillary wall to the blood. The capillaries then converge into larger and larger branches of blood vessels until they eventually empty into the dorsal blood vessel from here. Blood flows back to the heart and the circuit continues. Blood low in oxygen and high in carbon dioxide enters the right atrium through the superior and inferior vena cava. Large vein leading into the heart from above and below. Contraction of the right atrium forces blood into the right ventricles. The right ventricle contracts, forcing blood into the pulmonary artery. Branches of this artery lead capillaries in each lung where blood, high in carbon dioxide, picks up oxygen and gives off carbon dioxide. Oxygen-rich blood from the lungs move into the left atrium along 4 pulmonary veins. As the left atrium contracts, blood is forced into the left ventricle. A powerful contraction of the left ventricle forces blood into the aorta, which is the largest blood vessel in the body. Blood flows through the heart twice during each circulation of the body. That is, oxygen-poor blood, deoxygenated blood, flows into right side of the heart and into the lungs. Then oxygen-rich blood, oxygenated blood, flows from the lung into the left side of the heart, then forces under great pressure in the body. This kind of circulation is called double circulation. Type of circulation: pulmonary circulation. This is such in which blood circulates from the heart to the lungs and back to the heart through the four pulmonary veins. Systemic circulation. This is the circulation from the heart to all other parts of the body and back to the heart. Coronary circulation. This circulation supplies only the heart. Renal circulation. This form of circulation supplies the kidneys with blood containing urea to be filtered out in order to form urine. Portal circulation. This is an extensive system of veins which leads from the small intestine and stomach. They join to form the hepatic portal vein, which takes digested food to the liver. Functions of the cardiovascular or circulatory system. There are three main functions of the cardiovascular or circulatory system. Transportation. It helps in the transport of food. It helps in the transport of waste products from various organs to the liver and kidney. Transport oxygen from the lungs to the body and carbon dioxide from the body to the lungs. It helps in transport of heat produced as a result of metabolism. It helps in transport of active substance in the body, hormones and chemicals. It helps in the transport of trace elements, defensive functions. It helps in transporting antibodies, that is, immunoglobulins, platelets, leukocytes to infected sites by increasing blood supply to such area. Temperature regulation. The cardiovascular system plays an important role in temperature regulation to the skin. During high environmental temperature, the skin vessels dilate to release excess body heat, and during low environmental temperature, the skin vessels constrict, hence reducing body heat. Cardiovascular terminologies: cardiac cycle and properties of the heart muscles. The following are the terminology in cardiovascular or circulatory system. Heartbeat. The two sides of the heart work together and a complete cycle of heart activity is called a beat. Heartbeat. It has two phases. The first phase, this is called systole, when the ventricles contract and force blood into the arteries as well as the closing of atrioventricular valve. This is heard as a loud sound. The second phase, this is called diastole, when the ventricles relax and takes in blood from the atria as well as the sound of the closing of the semilunar valves. It is heard as the dub sound. The heartbeat originates from the heart itself in a small bundle of tissue in the right atrium. This bundle is called sinoatrial node, SA node. It is also called the pacemaker. Pulse is a series of waves of two forces, systole and diastole, that causes blood flow away from the heart. We feel our pulse by placing a finger over an artery which lies near the surface of the skin. The pulse pressure is the difference between the systolic and diastolic pressure. Systolic pressure is the pressure in the aorta, brachial and other large arteries. In a young adult, it can rise to a peak value of 120 mm mercury during each heart cycle, while the diastolic pressure is about 70 mm mercury. The pulse pressure is systolic pressure to diastolic pressure, that is 120 mm mercury minus 70 mm mercury is equal to 50 mm mercury. The blood pressure is the pressure in the brachial artery, or also referred to as arterial pressure. Its value is systolic pressure or diastolic pressure, that is 120/70 millimeter mercury, whether in a sitting or lying position. The arterial pressure is the product of cardiac output and peripheral resistance, hence it is affected by conditions that affect either or both of these factors. Cardiac output, Q. This is the blood flow generated by each ventricle per minute. The cardiac output is the volume of blood pumped by one ventricle, SV, per beat, multiplied by the number of beats per minute, HR. Q is equal to SV times HR. Stroke volume, SV. This is the volume of blood pumped by one ventricle or beat. Ventricular end diastolic volume, VE dV. It is determined by the volume of blood in the ventricle before contraction and arterial pressure. It is also referred to as reload. The stroke volume for each ventricle is 70 to 72 mL of blood. The SV varies with changes in the force of ventricular contraction. Heart rate, HR. This is the number of beats or minutes. It is affected by gender, age, body temperature, autonomic nervous supply. During exercise, Q increases to 25 liters per minute in a normal individual and 35 liters per minute in an athlete. Cardiac cycle. This is a series of events occurring in or by the heart. It is the same as a heartbeat. Each cycle lasts for about 0.8 seconds and consists of atrial systole, 0.1 seconds. Ventricular systole, 0.3 seconds, and complete cardiac diastole, 0.4 seconds. Properties of cardiac or heart muscle. Properties of cardiac or heart muscle include excitability. This is the ability of the heart, like any other living tissue, to respond to stimulation. One of the expressions of the heart is to generate impulse. Rhythmicity is the ability of the cardiac muscle fiber to discharge continuously and regularly when action potential is discharged from one point in the heart to the other. Conductivity is the ability to transfer action potential to all parts of the cardiac muscle from one point. Contractility. This precedes mechanical response after conductivity. It is the ability to contract when stimulated. 3. Conducting systems of the heart. The conducting system of the heart is an intensive function which is initiated within the heart by the conducting system that are specialized cells, low in contractility, rich in mitochondria, glycogen, exhibiting significant difference in electrical property compared with ordinary cardiac muscle fibers. Located within the walls of the heart are 4 structures that conduct impulse through the heart muscles to cause the atria to contract first and then the ventricles. These structures are sinoatrial node, SA node. This is called the pacemaker of the heart. It is found at the posterior upper part of the right atrium at the junction where the superior vena cava enters the right atrium. The isolated SA node has a firing rate of 90 to 120 beats per minute, which is higher in young individuals and decreases with age. The firing rate is increased by a rise in temperature, thyroid hormone, epinephrine, or norepinephrine. Interatrial tract, Bachmann bundle. This runs from the SA node to the left atrium. It causes almost simultaneous depolarization and contraction of both atria as the conduction velocity through the atrial muscle is very fast. Internodal tract. There are three bundles of specialized cells connecting the SA and atrioventricular AV nodes. They are the anterior, middle, and posterior internodal tracts. These tracts increase the likelihood that impulses from the SA node will reach the AV node to initiate ventricular depolarization, as internodal tracts are more resistant to blockage of impulse than atrial muscle. Atrioventricular AV node. This is found located beneath the endocardium on the right side of the interatrial septum near the tricuspid valve. It is normally the only path for excitation to proceed from the atria to the ventricles. AV nodal delay. This is the conduction velocity through the AV node. It is extremely slow, so that the ventricular depolarization is delayed for 100 to 150 milliseconds after atrial depolarization. This delay provides time for atrial contraction to occur, which enhances ventricular filling, especially in fast heart rates. AV node is richly supplied by fibers from both sympathetic and vagal nerves, which affect the conduction of impulses. Bundle of is atrioventricular bundle. This is continuous with the AV node and found beneath the endocardium on the right side of the interventricular septum. It divides into the right and left bundle branches. Purkinje fibers. These take its roots from both bundles branches and branches out extensively just beneath the endocardium of both ventricles. These cells have the highest action potential conduction velocity. Increased heart conduction velocity ensures that both ventricles contract almost simultaneously, thus increasing the effectiveness of contraction. Importance of the conducting system of the heart. The conducting system can help in restoring cardiac activities during heart failure if and when properly stimulated mechanically. 4. Electrography. The electrocardiograph (ECG) is a series of electrical events occurring within the heart during circulation. The electrocardiogram is the method of evaluating excitation events, arrhythmias, cardiac hypertrophy, myocardial damage, and presence of ischemia or necrosis. It is also a record of potential fluctuations during cardiac cycle. The ECG does not provide information on the mechanical performance of the heart. Action potentials. This is measured with the aid of a galvanometer within the ECG machine, serving as a recording device. They record potential difference between two electrodes. The ECG are recordings of differences in voltage between the two electrodes on the body surface as a function of time. Zero potential. This occurs during diastole when the cardiac cells are polarized, positively charged on the outside and negatively charged on the inside. The electrode placed on the skin do not detect voltage differences because all parts of the heart are equally polarized. Hence, the recording shows no deflection from the zero potential line. Action potential. Depolarization. Excitation of a portion of the heart causes the cells to depolarize, leading to a reversal of membrane potential in the area. The outside of the cell is now negatively charged with respect to the ground. A potential difference exists between the depolarized cells and neighboring non-excited cells. During repolarization, if the repolarization process proceeds in the same direction as depolarization, the galvanometer will be deflected in the opposite direction during repolarization process. Hentoven's triangle. This is a triangle with the heart at the center. It can be approximated by placing the electrode on both arms and on the left leg. Summary of study section 4. In this study, you have learnt about the peculiarities of the heart, its properties, and what enables it to carry out its function, the heartbeat, sound, and importance of the ECG, electrocardiogram. Now we've come to the end of study section 4. Thanks for listening.